Hello, this is Project How to Do, my name is Konstantin, and today I'll show you how I made this laser engraver from old DVD drives. Before we start, I have to say that, as most of my projects, it's easier and probably cheaper to buy same thing from China. And reason to making it by yourself is process of making. First we need two optical drives, CD or DVD, doesn't matter. Take them apart. We interested in carriage with step motors, guides and laser diodes. Remove the last one and all optical stuff. Those carriages will be our X and Y axis. We have to solid fix them perpendicular to each other. How to do that is up to your imagination. I have about 1 meter of aluminum angle and a piece of acrylic glass. I made the base from it and lift up the Y axis on tiny bolts. I fix the X-axis on aluminum angle and 3D printed bracket. Also, it's good idea to make rubber feet for the base. Next part is laser. If you took DVD RW drive, you can use laser diode from it for this project. Just make a simple driver. I also have a video how to do that. But I'm going to use 1.5 445nm laser module that I made in this video. Also I leave links to different laser models. Of course, for a long time work we need to cool down the laser. For DVD it's maybe enough just a little piece of aluminum, but in my case I need active cooling. I print this bracket to hold laser diode with driver on a heatsink and 50mm fan. Also because air only coming out from the bottom, I solve the problem with smoke extraction from engraving surface. Laser protection glasses is must-have for this project. It's only cost a few dollars, but don't save on your health. For table, any smooth surface is good. I use 3D printer again to save time. Let's move to the electronic assembly. For the brain I have an Arduino Nano. Also we need two step motor drivers A4988. MOSFET, RFZ44N, couple resistors 47 ohm and 10K. Power supply for motors and laser is 12 volts and at least 3 amp. Power for Arduino right through the USB. I think circuit is pretty simple, but if you have any question, feel free to ask. The most attentive of you could notice this heatsink. The fact is that I bought laser driver for one lithium battery, which is about 4 volts. So this is LM317, step down DC-DC, from 12 volts to 4 volts. Of course it's heating very much. I built everything on breadboard but forget to film. So let's look how I solder it to the board. MOSFET don't need a heatsink, it should be cold. Before adjusting we have to upload a firmware. I using GRBL 1.1. Go to this website, download it. We only need a GRBL folder. Add it to zip archive. Then in Arduino IDE, go to Sketch, include library, and add zip library, and choose GRBL archive we just made. Then open an example called GRBL upload, and upload it to your Arduino. Also you need a software to send G-code to engraver. I tried some of them and best for me is Laser GRBL. Choose COM port with Arduino and speed of 115 and 200, connect and send $2 signs to get response from the board. Back to electronic. We need to set up the right current for step motors before connecting it. Plug in 12V power supply, Arduino to PC, and measure voltage on trimmer potentiometers. You can calculate it from this formula, but because we probably don't need the right current for our motors, set about 250 mV and connect motors. One of them was heating too much, so I lowered voltage to 130 mV. Second is missing steps, and I raised the voltage to 350 mV. Those 3 pins of drivers is resolution selector input, connected to plus, but keep in mind that one of my step motors doesn't work with 16 step size, and I'm using only 8. At the same time with this setup, try to move the axis from LaserGRBL software, using those arrows. For an emergency stop, push button with lightning. Next step is program setup. Connect engraver to PC and send $2 signs. You get a list of parameters that is stored in memory of Arduino. We interested in lines number 30 maximum laser PWM. When you set this value, you get 5 volts on D11 Arduino pin. You can leave this parameter as it is, but I changed it to 256. This done by sending such a command. 32 is laser mode. You need to send 1 to this parameter, same as previous paragraph. Line 100. How many steps the motor should make to go 1 mm along the x-axis. 101, the same for y-axis. These two parameters must either be calculated, but you need to know the pitch of motor axis, or draw something, measure the real dimensions of resulting, and change the parameters. Lines 130 and 31. The maximum dimensions along the x and y axis. Usually about 35 mm, depends on the drive. In order to set the focus point, we need to turn on the laser. To do this, you need to send those commands one by one. That will launch the laser at 10% of power. The last important point is that we don't have limit on the axis, and the place where motors are at the moment of turning power on will be set as 0 coordinates. So before power the engraver, you need to set the axis to maximum position, pull out Y and X maximum to the right. Pictures are uploaded very simple, just choose the file. It can be either already prepared G-code or regular picture in JPEG, PNG or BMP. That's all I got for today. If you like it, please share it in social media, it's really help. See you next time!